TV for U1, Chapter 3, Application of Derivatives, Session 6. In this session, we are going to work on question assigned in Session 5. Exercise 3.2, Question 3, Part D. F of x equals x3 minus 3x2 when x is between -2 and 1. Determine the absolute extrema of the function on the given interval. Illustrate your result by sketching the graph of each function. We find the derivative of f of x. Derivative of x3 is 3x2. Derivative of minus 3x2 is 6x. If we set the derivative to 0, x would be either 0 or 2. 3x2 minus 6x is 3x times x minus 2. 2 is not admissible. We evaluate the value of f when x is -2, 0, and 1. F of -2 is minus 20. F of 0 is 0, and f of 1 is -2. Therefore, maximum of the function is 0 when x is 0, and minimum of the function is -20 when x is -2. The graph of f of x is between -2 and 1. The red portion of the graph is the graph of the function. The minimum is -20 and the maximum is 0. Next question. F of x equals 1 over 3x3 minus 5x2 plus 6x, x between 0 and 4. The derivative of this function is x2 minus 5x plus 6, which is x minus 2 times x minus 3. Therefore, 0, 2, 3, and 4 are critical numbers and endpoints. F of 0 is 0. F of 2 is 14 over 3. F of 3 is 9 over 2. And f of 4 is 16 over 3. Maximum of the function is 16 over 3 when x is 4, and the minimum of the function is 0 when x is 0, both at endpoints. The graph of the function when x is between 0 and 4. 4 is 16 over 3, which is a little bit more than 5. The graph is similar to this if you use a graphing calculator. Maximum and minimum. Next question. Using the algorithm, finding the maximum minimum of the function, determine the absolute extrema value of each function using the algorithm, as we said. First function, f of x equals x plus 4 over x. When x is between 1 and 10. The derivative of f of x is 1 minus 4 over x2. It is x2 minus 4 over x2. It's good to know the derivative of 1 over x is negative 1 over x2. We already talked about this a couple of times. Therefore, at negative 2 and 2, derivative is 0. Negative 2 is inadmissible. We need to calculate the value of the function at 1, 2, and 10. At 1 it is 4. At 2 it is 2 plus 2. At 1 it is 5. 1 plus 4 is 5. At 2 is 2 plus 2, 4. At 10 is 10.4. Maximum and minimum. Minimum is 4 when x is 2. Maximum is 10.4 when x is 10. The next part, f of x equals 4x over x2 plus 1. To find the derivative, we use quotient rule, x between 2 and 4. Derivative of f over g is f prime g minus g prime f over g2. F prime is 4, g prime is 2x. Derivative of numerator is 4. Derivative of denominator is 2x. 4 times x2 plus 1 is 4x2 minus 8x2 minus 4x2 plus 4 divided by x2 plus 1 to the power of 2 is the derivative of the function. At 1 and negative 1, derivative is 0. Negative 1 is not within the interval. 1 is also not in the given interval. Therefore, we have to calculate the value of the function at endpoints 2 and 4. The value of the given function at x equals 2 is 8 over 5, and at 4 is 16 over 17. Eight over 5 is the maximum of the function, and the minimum is 16 over 17. Question 6. A swimming pool is treated periodically to control the growth of bacteria. Suppose that t days after a treatment, the number of bacteria per cubic centimeter is nt equals 30 T2 minus 200 for dt plus 500. Determine the lowest number of bacteria for the first week after the treatment. We are looking for the minimum of nt when t is between 0 and 7. Notice that t is the time, and it is per day, and derivative of nt is 60t minus 240. If we set it to 0, we get t equals 4. At the beginning, at the end of the week, and after 4 days. When t is 0 and t is 500, after 4 days, the number of bacteria is n at 4, which is 20, and after 7, it is 290. Number of bacteria is minimum after 4 days, and it is 20. Question number 7. The fuel efficiency E in liter per 100 kilometers for a car driven at the speed of V in kilometers per hour is EV equals 1600 V divided by V2 plus 6400. EV equals 1600 V over V2 plus 6400. Part A. If a speed limit is 100 kilometers per hour, determine the legal speed that will maximize the fuel efficiency. We are looking for the fuel efficiency when V is between 0 and greater or equal than 0 and less or equal than 100. We need derivative of this function, quotient rule, derivative of numerator times denominator itself, minus derivative of denominator times numerator divided by denominator to the power of 2. This can be simplified as minus 1600, if we factor 1600 as well, times V2 plus 6400, minus 6400. Divided by V2 plus 6400 to the power of 2. Notice 1600 V2 minus 2 times 1600 V2 is negative 1600 times V2. If we set it to 0, V would be either 80 kilometers per hour or negative 80 kilometers per hour. Negative 80 kilometers per hour is not acceptable. V, EV, at 0, it is 0. At 80, it is 10. And at 100, it is 9.756. Efficiency is maximized when V is 80 and its maximum is 10. Part B, repeat part A using a speed limit of 50 kilometers per hour. In this case, we need to find the value of EV when V is 0 or 50. At 0 it is 0, and at 50 it is 9. None of the roots of the derivative is within the interval. They are not between 0 and 50. Part C, determine the speed interval within the legal speed limit of 0 to 100 kilometers in which the fuel efficiency is increasing. Fuel efficiency is increasing when its derivative is positive EV is increasing when E prime V is positive, and it is decreasing, which is the part D of the question, when E prime V is negative. If we draw the sign chart for E prime V, we'll see between 0 and 80 it is positive, and between 80 and 100 it is negative. Therefore, for V is between 0 and 80, fuel efficiency is increasing, and at 80 it is maximum, and after 80 it is decreasing. So we answered part D as well. Next question, question number 10. A truck traveling at X kilometers per hour, where X is between 30 and 120. Uses gasoline at a rate of Rx liter per 100 kilometers, where Rx is 1/4 times 4,900 divided by X plus X. If fuel cost is $1.15 per liter, what speed will result in the lowest fuel cost for a trip of 200 kilometers? And what is the lowest cost? We are looking for lowest cost. Cost is the price times rate. Price is constant, therefore we have to minimize Rx. The derivative of Rx is 1/4, which is constant, times derivative of 4,900 divided by X, which is 4,900 times negative 1/x2 plus 1. If we set R prime of X equal to 0, 4,900 divided by X2 would be 1. X2 equals 4,900, X equals plus minus 70. Therefore, X equals 70, because negative 70 is not possible. We are looking for minimum of Rx when X is between 30 and 120. R at 30 is 0.448, R at 70 is 0.35, and R at 120 is 0.4. The minimum rate is 0.35. So the speed of 70 kilometers per hour uses fuel at a rate of 0.35, which is 0.35 liters per kilometer, which is the minimum. Cost of the trip is 200 kilometers, 200 times rate times price per 100 kilometers. Price per is $1.15 per liter. If price per liter, if we multiply this, we have the cost of the trip. Thanks for watching.